Hi everyone! Triangles. Basically, there are three types of triangle: equilateral triangle, isosceles triangle and scalene triangle. Are we forgetting about some triangle? Yes, a right-angled triangle. It's just a triangle with one angle as 90 degrees. For all these types of triangles, we have only one formula to calculate its area. Whereas, we have learnt that all different types of quadrilateral have different formula for their areas. Isn't this little unfair for triangles? Till now, we have been studying that the area of triangles is calculated using the formula half multiplied by base multiplied by height. Now suppose if you have a huge triangular complex and we only know the length of each side of the complex. Let's say 4 kilometers, 5 kilometers and 6 kilometers. Now, if I ask you to calculate the area of this complex, can you calculate it using the given formula? If we want to use this formula, we need the height of the triangular complex, which we do not have. But with the given information, we can calculate the perimeter of the complex, which is nothing but the addition of all the sides. Why are we doing this? You will come to know in the later part of the session. What do you think? Are we the first ones to come across with such a problem? No. Let's go back in history. In 10 AD, a great applied mathematician named as Heron was also equally interested to figure out this answer. He tried to replace the value of h in terms of a, b and c, so that we do not need the value of h to calculate the area. Let's have a brief look at how the formula was derived. First, we take any random triangle and let the side lengths be a, b and c. Here we draw a perpendicular height and say it h. Now, we have two right-angled triangles. And as soon as we see right-angled triangles, the first thing that comes into the mind is Pythagoras Theorem. So let's apply Pythagoras Theorem in both these triangles. Now we have equation 1 and 2. Let's subtract both the equations and get the value of x in terms of a, b and c. Now using equation 1, we can also get the value of h. Now all we have to do is put the value of h in the formula half into base into height. Let's take c and half inside the square root. Now after solving it further, we come to a step where we only have perimeter and sides in the formula. Here we can see that perimeter is divided by 2 everywhere. So, we replace that with S, which is nothing but semi-perimeter. And now we have arrived to a formula which says that area of triangle is equals to under root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. He finally came up with a formula that can calculate the area of triangle without its height and by using only the side length information and its perimeter. And actually the formula is very easy to remember also. How? We have to subtract all the sides with the semi-perimeter and multiply everything with the semi-perimeter again and take a square root of it. You may find it a little difficult, but the more you will practice, you will get a hang of it and you will find it easy too. So here, we do not need the value of height and now we can find the area of the complex with the sides 4, 5 and 6 kilometers. So the area of the complex comes around 9.921 square kilometers. Now this formula is used for all the types of triangles to calculate the area if the value of the sides are given. Do you remember we used the formula half into base into height to find the formulas to calculate the areas of quadrilaterals? Now here we are going to use Heron's formula to calculate the area of quadrilaterals. Now you may ask, which type of quadrilateral? It may amaze you, but using this formula we can calculate the area of any type of quadrilateral if all the required lengths are given. Let's have a look at one interesting example that how we can calculate the area of quadrilateral using Heron's formula. Suppose there is a geometric patterned flower. Each of its petals is same and is of kite shaped with lengths of sides as mentioned. We have to calculate the area of the flower. This may look complicated, but it's very simple. All we have to do is find the area of 1/2 of the petal using Heron's formula. Now, as there are total 10 petals, we will multiply it by 10 to get the area of the flower, right? No, we will multiply it by 20 because we have calculated only the area of half of the petal. Isn't it? This could have been a very natural and tentative mistake and yet a very stupid math mistake which could have been avoided easily just by concentrating a little more. I hope this session has helped you to know more about area of triangles and few things about quadrilaterals too. Do like, comment and subscribe to our channel, Let's Tute. Till then, keep watching, keep learning. Thank you.